Hi, welcome back to Chapter 3 Gravitation. Congratulations, okay, we have done until number 8 in performance evaluation. So today I want to discuss the rest of the questions starting from number 9 to number 13. So you can refer to page 114 in your textbook. Let's get started. Okay, number 9. Figure 5 shows a planet Saturn with rings made up of small particles around it. Planet Saturn has mass of 5.68 times 10 to the power 26 kg and radius of 6.03 times 10 to the 7 meter. A. Calculate the escape velocity of planet Saturn. B. Discuss the possibility of the small particles in the ring of planet Saturn escaping into the outer space. Alright, look at the solution A. So in order to solve calculation problem, you must know how to use the formula that we have discussed in chapter 3. Okay, escape velocity of Saturn, so V equivalent to square root of 2gm divided by r. So G is universal gravitation constant, m is mass of Saturn, r is radius of Saturn. So remember, if we calculate for Earth, then m is mass of Earth, r is radius of Earth. Here we calculate for Saturn, so m must be mass of Saturn, r must be radius of Saturn. So you substitute all the values, so you calculate, you get 3.54 times 10 to the power 4 meter second negative 1. Okay, for B, part B, in order for the small particles to escape from the atmosphere of Saturn, it must exceed the escape velocity of the Saturn. So from here we get a very large escape velocity. So meaning it is impossible for these small particles to escape because the escape velocity of planet is very high. So the small particles not able to achieve the escape velocity of Saturn. Thus it cannot escape to outer space. Okay. For number 9, figure 6 shows three bodies A, B, C. It is given that gravitational force between A and B is P. Okay, from A and B, P. State in terms of P, gravitational force between B and C, A and C. So you must remember the formula that we use for gravitational force. F equivalent to G m1 times m2 divided by r squared. Okay, let's say the first part, part 1, given between A and B is P. So the gravitational force between A and B we mark as FAB equivalent to G times mass of A 100, mass of B 100, and then the distance between center to center is 5 meter, so 5 squared. Then we get P equivalent to 400 G. So you can just write in terms of G because later on the G will be cancelled. Okay, so just mark as 1. Okay, part 1 between B and C. B and C, mass of B is 100, mass of C is 200. So between B and C, we mark as FBC. Then G, M for B, multiply M of C, divide by distance between B and C. So 5 squared. So we get FBC equivalent to 800 G. Remember, 400 G is equivalent to P. So 800 G meaning equivalent to 2P. So meaning in terms of P, we get FBC equivalent to 2P. Okay. Part 2, A and C. A and C distance between equivalent to 5 times 5, 10. A is 100 kg, C is 200 kg. Okay, so FAC equivalent to GMA times MC divided by 10 squared. So we get FAC equivalent to 200G. 200G is equivalent to half of P. Okay, so here is P equivalent to 400G. So FAC is 200G, meaning FAC equivalent to 0.5 P. So we get the solution. So this one just play with the formula. Okay, number 11, table 1 shows information in the 3 types of orbits X, Y, Z for satellite orbiting the Earth. Okay, so you see here we have X, Y, Z. So the shape of orbit, height of orbit, orbital periods are given. A space agency wishes to launch 2 satellites P and Q to orbit the Earth. Satellite P is an Earth imaging satellite that can capture images of various locations on the surface of the Earth, while satellite O satellite Q, is a communication satellite. So you must remember that day we have discussed about geostationary satellite and non-geostationary satellite and its uses or function. Okay, so you can use that information to solve or to explain this question. Okay, using the information in table 1, determine which orbit is suitable for satellite P and satellite Q. Explain your choice. Okay, so remember this one P, I'm underlined with the red color here. P is Earth imaging satellite, capture images of various locations. And satellite O is communication, satellite Q is communication satellite. Okay. Okay, the solution. So for satellite P, imaging satellite with the following features. Actually, this one is non-geostationary satellite. So for non-geostationary satellite, number 1, part 1, we discuss about its orbital height. Orbital height is small so that clear photograph can be taken up from the surface of the Earth. Part 2, orbital period is less than 24 hours, so it can orbit the Earth several times a day. The satellite will be at different locations above the surface of the Earth, then can take photograph in many different places. Okay, third point, elliptical shape orbit so that near and far photographs can be taken. Therefore, satellite P needs to be placed in orbit X. So actually this type of question you can write in table form. First you just explain the aspect and then give explanation for the aspect. Okay, so meaning P as an imaging satellite that need to record various location, okay, of images. So meaning it need to able to change location or geographical location. So meaning the orbital period is less than 24 hours. Okay. For Q, this is geostationary satellite. Okay, orbital period of 24 hours so as to rotate together with Earth and maintain the same location above the surface of the Earth. This satellite can receive and transmit communication signal to stations on Earth. Round orbit so that its height from the surface of Earth is constant. Therefore, satellite Q needs to be placed in orbit Y. So this is the geostationary satellite, communication satellite. Okay, number 12. Assume you are a scientist. Your group has found a new system of bodies. The system is made up of a star at the center and 5 planets in circular orbit around the star. Table 2 shows information of the system of bodies. Okay, so you have a star, planet A, B, C, D, E, mass, radius, and radius of orbit. A. Calculate the gravitational acceleration, escape velocity, and orbital period of each planet. So you must know the formula how to calculate gravitational acceleration, escape velocity, and orbital period. Okay, so you must calculate for each of the planet here. Okay, so we can look at the formula that we need to use. So gravitational acceleration, we use the formula G equals gm divided by r squared. Escape velocity, V equivalent to square root of 2gm divided by r. Orbital period of planet, T equivalent to square root of 4 pi square r cubed divided by gm. So you must know all the formula here. So here all the values are already calculated for you. So what you do, you can pause this part and then you calculate one by one and check whether you get the same answer or not. So that one, you calculate for the first part. Okay, B, how do the values of gravitational acceleration, escape velocity, and orbital period influence the suitability of a new planet to be inhabited by humans? So you must know the effects of gravitational acceleration, the escape velocity, and orbital period towards the human. So how can human live on that on that planet. Okay. So B. So first we discuss about the value of G, gravitational acceleration. Value of G will determine a body weight of humans. A value of G that is too small or large will cause blood circulatory system and fluids as well as internal organs in the human body to not function normally. A high enough escape velocity will ensure a planet has an atmosphere that is thick enough for human needs, meaning enough oxygen or enough air. Orbital period will determine changes in weather and season cycles. A period that is too short causes changes to happen too quickly and it is not suitable for plants. On the other hand, too long a period causes each season to last for too long. For example, summers or winters that are too long. So this is not really suitable. If you look at if you have very long winter, so what happened towards the human health? Okay, so this is all the value that we discussed. Okay, we go back to the question before, the part C. Choose the most suitable planet to be inhabited by humans. Give a reason for your choice. Okay. So here we have calculated everything. We have gravitational acceleration, escape velocity, and orbital period. So we just use the information that mentioned here. Okay, so gravitational acceleration of the Earth equivalent to 9.81 meters second negative 2. Escape velocity of the Earth 1.12 times 10 power 4 meters second negative 1. Orbital period of Earth around the Sun is 1 year. You check the planet B. The planet B has a gravitational acceleration closest to that of Earth. So if the difference is too big, it will give really big impact to the health of the human. Okay, so human can live comfortably with a few adjustments. Escape velocity of planet B is not too small compared to the escape velocity of Earth. There is a high possibility that layer or atmosphere of planet B is thick and dense enough for human needs, meaning enough air. Orbital period of planet B is about the same as the Earth. So planet B is chosen to be inhabited by humans. So meaning you must know all the values of G, the orbital period, and the escape velocity of the Earth. So we need to find the planet which is quite the same in terms of its G, okay, escape velocity and orbital period. Okay. Okay, number 13. Assuming humans have successfully inhabited planet Mars, you and a group of scientists are required to invent a system of man-made satellite around Mars. The man-made satellite consists of weather satellite, planet surface mapping satellite, and communication satellites. Table 3 shows information on planet Mars. Okay, so we have here all the information. Based on the information in Table 3, propose the characteristic of the satellite orbit in terms of orbital height, orbital period, linear speed of satellite, launch base, as well as the other suitable factors. Okay, this one is one essay question. Okay, for number 13, the atmosphere of Mars is about 100 times thinner than the atmosphere of Earth. Satellite can orbit closer to the surface of Mars as compared to Earth and still not experience a large resistance. Weather forecasting satellite and imaging satellite need to be in a lower orbit or shorter orbital period than period of revolution of Mars. Communication satellite need to have the same orbital period as period of revolution of Mars. So from the formula, velocity of the satellite V equivalent to square root of gm divided by r plus h. So orbital period around Mars, we can calculate T equivalent to square root of 4 pi squared, r equivalent to r plus h, cube divided by gm. So here, for the weather forecasting satellite, so we can suggest a value of orbital height, like h equivalent to 200 kilometer. So it's 2 times 10 power 5 meter. So velocity of the satellite V we calculate. So we get 3.45 times 10 power 3 meter per second. Orbital period, we get 1.82 hours. Okay, so this is for weather forecasting satellite. Suggestion for imaging satellite: orbital height that is slightly more than the weather forecasting satellite, so H equivalent to 250 kilogram. So velocity of the satellite equivalent to 3.43 times 10 power 3 meter second negative 1. So use formula that we have mentioned before. Orbital period, so you use the formula, so you will get 1.86 hours. We get the answer in second, then you calculate, you divide by 3,600, then you get 1.86 hours. So suggestion for communication satellite: orbital period equivalent to 24.6 hours, about the same as the orbital period of Earth. Direction of motion of satellite is same as direction of rotation of Mars. Orbit above the equator of Mars. Orbital height is calculated using the formula here. So we calculate. So we get R equivalent to 2.04 times 10 power 7 meter. So orbital height, we take H equivalent to the total distance between center to center minus radius of Mars. Then we get height of the satellite from Mars. Okay, so velocity of the satellite V, we have the formula. Okay, GM divided by R. So we have 1.45 times 10 power 3 meter per second. So all three satellites are launched from a base close to the equator of Mars, so that distance traveled to the desired orbit is shorter. This saves on fuel consumption. Time of motion in atmosphere is also shorter. So that is the end of the chapter 3, gravitation. So do more reading and exercises for better understanding. So work harder, so in order to rocket to success. Okay, that's all. Bye.